Okay, so lesson 2.2, creating exponential equations. I learned an objective for today. Students will create exponential equations from real-world applications consisting of graphs and tables. All right, let's dive right into it. All right, so yesterday you guys had a little U-try activity, and the U-try activity was just based around kind of making sure you guys understood function notation. All right, and as we recall from yesterday, looking at the notation for like number 1, it's basically saying that when my x is 2, because since the 2 is inside the parentheses for the notation, it's basically telling me that my x is 2. So that means they're saying find the value of f of 2. So basically what they want to know is when x is 2, so when I go to 2 on my x-axis, which is right here, what would my value for y be, which would be this value right here. So when I go up on 2, I see that this point is there. All right, and if I look here and I go straight over to my y-axis, it corresponds to 2 on my y-axis. So this point would be 2 and 2, of course. So the value for f of 2 would just be 2. All right, and so when I look here, this on the other hand is letting me know, it says f of x, or find where f of x is equal to 4. So when f of x, which is y, which we recall from the video yesterday, f of x is the same thing as saying y. So this is telling me that on my y-axis is 4. Well, I know that it creates this point right here, and so I need to look and see where my x value would be, and I can clearly see that it would be at 4. So here, it would definitely be 4. Okay, and so this one says find y when x is 6. So they gave me my x value is 6. So I go over to 6 here. So I know that my point is going to be somewhere here. All right, now since I have my point, what y value does it correspond to? All right, and I can see that it clearly corresponds to 8. So f of 6 would clearly be 8. And this is saying when y is 16. Okay, so I come over here on my y-axis to 16, and I go straight over until I intersect with the curved figure here, and it makes a point here. And if I go straight down, I can see that it corresponds to a value of 8 on my x-axis, and so that would be the point there. Now, so if I look at all of these values here, all of these values is nothing more than values that are like ordered pairs. So looking at this is saying when x is 2, y is 2. So over here, if I wanted to create a table, I could display it on a table. So this is basically saying when x is 2, y is 2. This is saying that my y is 4 and my x is 4. So over here, displaying that on the table, it would be my x is 4 and my y is 4. This is saying that my x is 6 and my y is 8. So over values would be 6 and 8. And last but not least, this is saying that my y is 16 and my x would be 8. So over here, my y would be 16 and my x value would be 8. So if I were to create a table, this is what it would look like. Okay, so yesterday we looked at the exponential equation, and we understand that a or b cannot be 0. We also understand that these type of equations, because x is actually acting as an exponent right now, it creates a curve-shaped figure, with sometimes that curve-shaped figure can increase and sometimes that curve-shaped figure can decrease, which we call that either a growth or a decay. All right, so today our objective is to create some equations. So our a value is always going to represent our starting amount. So as we're looking to create equations, anything that goes inside this a value is going to be where we start at. All right, and for our b value, that b value is going to be either our growth value or our decay value, meaning how fast something is growing or how fast something is actually shrinking, all right, or not growing. So let's move on. Let's look at some examples in everything that we do. So here, the first example, it says, and we're going to try to create an equation based off of what the information that is given us. So the first says the growth in the table is doubled. Okay, so wow, it's doubled at a whole at each whole year. All right, so we have to understand what this double means. Well, do you think this double would represent our starting amount? Or do you think that's going to represent the factor how we're increasing? That's right. If you said increasing, you were absolutely right. Now, if I look here at the graph, I understand that this graph, or not this graph, but this table, let me help you to understand what this table is saying. So, first of all, this table is talking about years. So I got 0 years, I got a half a year, I got 1 year, I got 3.5 years, I got 2 years, I got 5.5, I got 3 years, and so forth and so on, all the way till we get to 4 whole years. Now, this is telling us the amount of bacteria that I have. Okay, so we can imagine, maybe say bacteria on a kitchen surface or something like that. Okay, so I started out, okay, or I have 2 bacteria, then I got so many bacteria, then I got, after 1 year, I have 6 bacteria, and then after 3 years, after 4 years, well, I don't know, that's what I need to figure out. But in order for me to figure that out, I need to first create an equation. So if I look here, so 0 years has occurred, so this must mean where I start. Okay, so I start at 0 years because nothing happened. So this is what I started with. I started with 2 bacterias, okay? So if I'm starting at 2 bacterias, which is my starting amount, and it's doubling, if I go up here, it's doubling each year, my equation is going to look like this. Because if we remember that this value in the blue, where I have this 2 at, this is always what we start with. So we started with 2 bacteria. This value here is our how much we're increasing or decreasing. Okay, and you can see that it's being doubled each year. So this is what our equation would look like. So now, how do we get the rest of these values in? Well, now everything is easy. I have an equation, so I'm going to plug this into Desmos. I'm going to go f of x, and that is equal to 2, and I'm going to raise that to the power of x, okay? And easily, I'm going to just look at a table. In this case, I want to look at my table. And so you can see the various values. Oh, but I don't see half values. But could I get those? Absolutely. So I go to my table and I see that my X column, it represents my years. My Y column is representing the growth of the bacteria. So let's see how much bacteria we're going to have after a half a year. So I put in 1/2 of a year, and I see that it grows to like 2.82 bacterias, okay, after half of the year. All right, so there, 2.83 bacterias, that's what it says. So now I'm at a whole year, and if I go up here to my table at a whole year, I should be at... Okay, so as you can see, I kind of made a mistake again. And so let me put this back up here. And so as you can see, we were here. So after 1 year, we can clearly see from the table that we have constructed here that we now have 4 bacterias. All right, so now after 3.5 years, we can come over here and figure out how much bacteria we have by putting the fraction in 3 divided by 2. And it should tell us that we should have 5.65, and I just rounded it up. Okay, and after 2 years, we should have 8 bacterias in there. And then after 5.5, I'm just gonna continue 5 divided by 2 in there, and this should be a 1. After 3 whole years, 3 isn't up here, so I did no problem. I just put 3 in there, and I should have 16 bacterias built up after 7.5 years. So let's see, 7 divided by 2. I should have 22. And there you go. And after 4 total years, I put in 4, I should have 32 bacterias that are added up. And so as you can see, the number of bacterias, they're growing. They're growing. So automatically, I know that this is probably exponential growth. Okay, because every year, all this bacteria is becoming more and more. All right, so let's look at the second one. It says the growth in the table grows by a factor of 5 each year. Oh, how many did we start out with for this bacteria? 2. But this time we're growing by a factor of 5. So my equation would be 2, because this is our starting amount, times 5, and that's raised to the power of x. So guess what? I go over here and I just do the same exact thing. I put my equation in and say f of x, and that is equal to 2, open parentheses, 5 this time, because that's our growth factor, and that's raised to the power of x. All right, so very quickly, I want to view the table because that's what I'm going to be using. And so I don't see any fraction exponents in there, or fraction years in there, so let me put some in there. So I need to know 1/3, so I'm going to put 1 divided by 3, and quite naturally I should get this value here. And then for 2/3, come over here, 2 divided by 3, and I get this value here. And so as you can see, at 1 year, this is where you're at, 10. Okay, and at 4/3 of a year, okay, I should have this amount of bacteria that's built up, 5/3. I should have this amount of bacteria build up. And then at 2 whole years, I should have 50. Wow. So that is growing increasingly. And at 7/3, I should have this much bacteria build up. And lastly, at 8 divided by 3, I should have this much bacteria build up. So quite naturally, if you compare the two graphs, you can see that for graph number 2, or for table number 2, your bacteria is growing at a much faster rate. Because look at here. Look at the rate. Look at after 2 years, you've had a total of 50 bacteria that have grown. Here at 2 years, you only had 8. So you can see that the growth factor, it kind of amps it up a little bit, and it grows it a little bit faster. Okay, so exponential equations. Let's look at a little scenario here. All right, so we got a lemonade stand. And guess who's working this lemonade stand? Well, you have Woody. You guys remember Woody? We have Timmy Turner, and we also have Minnie Mouse. They are kind of collaborated together, and they wanted to run this lemonade stand over the summer to try to make a little extra money. Okay? Now, they're earning interest annually. What is annually? Annually means every year. So every year they're going to earn 5% interest on their money. Okay, now let's close this out. All right, so they're earning 5% interest on their money every year. They're starting out with $382.88 in their account to kind of help fund this whole lemonade stand project that they wanted to create. And as you can see, Minnie is very happy about that. Yeah, she looks very happy, and Timmy looks very energetic. So our starting amount is going to be $300 and $382.88. That's what we're starting with. What's our growth? How are we growing? At a 5% rate. Okay, so 5%, we have to change that to a decimal. Okay, so 5% written as a decimal just changes to 0.05. Okay, now the only difference is because these are percents, okay, I have to add 1 to it. So I have to do 1 plus our rate to get how much money we're going to accumulate from year to year. So this would be the equation that I will use to help me to kind of generate some information about how my company is going to be doing if it's growing at this annually rate, okay? And I have this much money in my account. All right, so now let's look at some numbers here. So we're going to look at a table, and as you can see, Minnie, Woody, and Timmy Turner, they've been doing so good, and they were able to start out with some money. That's always a good thing. And after the first year, they've accumulated $402.02. After the second year, they've accumulated $422.12. After the third year, you can see here what they have. After the fourth year, you can see what they have. But guess what? They're on their fifth year. And they want to try to calculate based off of the information that they know. Well, they want to know how much money they're going to have in their account after 5 years, because they're very eager. You know, they want to kind of see where they're going. So to do that, we're going to put that equation that we created, and we're going to go f of x is equal to $382.88, and that's going to be 1 plus 0.05%, and we're going to raise that to the x power. Okay, that's our equation. Now, I'm going to go here and I'm going to change it to a table because I want to witness this table. And as you can see, our table values kind of correlate. Look at this. They're the same values. So we know we got our equation correctly, but we're more interested to find out, well, let's look here. Let's put 3 years. So 3 years, you can see that the values kind of line up. And 4 years, you can see that the values kind of line up. Now, here we go. How much money am I going to have in my account after 5 years? Well, after 5 years, you can clearly see that Timmy Turner, Minnie Mouse, and Woody are going to accumulate a whole $488.66 in their account, okay, which they'll eventually have to split 3 ways. But it's okay because it's more money than they have in their pockets right now, okay? And maybe leaving it in there longer might get them more money, so they might want to consider that. All right, so let's look at this. Now, so Minnie, she became so intrigued, okay, by this whole money idea, because everybody likes money, right? So she wanted to look at, well, you know, what was our account looking like in previous years? I wonder if I could calculate that. And Timmy was also kind of curious as well, but Timmy was confused. What do you think the negative values mean? Timmy asks. Okay? And so, quite naturally, of course, here we have negative values. Well, we have negative values here on this table. What do you think those negative values mean? Well, this is where we started with. Okay, this is where we went to the bank and we put this money into the bank, and this is what we had to start with. But prior to starting with this amount, this is what we had. Okay, prior to that, this is what we had. Prior to that first year, this is what we had. Prior to that second year, this is what we had. Prior to that third year, this is what we had. So as you can see, these negatives means that we're kind of going backwards, and we're talking about the years before where we're at now, or where we actually started. Okay, so let's look here. So we can see at 5 years, and we already know where we're going to be at 5 years. We figured that out in the last example there. Okay, so at 2 years ago, where was I at? Well, I just quite naturally come over here, and I can see clearly I plug in negative values here, and I can see that after 2 years prior to where I'm currently at, this is where I was at. What about 3 years? Well, I just come over here and I put that -3 in there, and this is where I should be at. Look at there. That matches up. What about 4 years ago? Well, 4 years ago, this is where I'm at. All right, and I kind of rounded there. I said 315 roughly, but you guys can kind of pick and choose. And actually, my numbers are wrong because it should. And actually, my numbers are a little bit off because actually it should be just $315. So I should probably scratch this right here off and just put $315 if I was really rounding that up. Okay. All right, and then after 5 years, well, or 5 years ago, I was at $299. Well, you can see how much they've increased. All right, so Woody stepped in, and Woody said, Timmy, I have a solution, or I have an answer to your question. And the negative values tells us the amount the account has from the past years. Okay, all right. So now we've kind of listened to Timmy and Minnie and Woody, and we understand how important rates and exponential equations kind of grow. We understand how to figure out these amounts based off of the equation using desmos and things like that. So we're going to go and try some on our own. All right, and we're going to come back tomorrow and discuss that.